Okay, so let's consider a little bit of a different situation. This is kind of a smattering of parameters, but within this situation I'm going to show now, we have a variety of link distances, and we also have notably each repeater has only a finite probability of success of actually performing a swap at each time that it tries to. In particular, here we have a probability of 45%, and each memory has a coherence time on their qubits, beyond which the fidelity of their qubits will go too far low. And so in this case, we have a whole lot of other things that can happen. So let's see what happens here. There's not the right one. Okay, so here I've run the same simulation, but just specifying all of these coherence times and the probabilities of success and the distances. Okay, so that's now run. Right. I should just be able to go. Now, what does it look like? Oh, looks different colors. Okay, so now we start off the same, right? We say, okay, let's get going. Make me some entanglements, and we start off with our elementary entanglements. But now, when our repeaters go to swap, they have a probability of failure, and so that's what the red is represented. And when that happens, they also have to often message their neighbors that I'm sorry, I had an entanglement failure. And so what we have here is we have two failures happening and one success, and then they are then messaging each other, saying, okay, I failed. And then here we actually because this middle node realized that there was no chance of properly swapping because we had failures here and here, he goes, okay, I'm going to restart, get two more basic entanglements, try again, but failed. And so you'll find that they kind of go through this dance a little bit. Here we have a case where these nodes have determined that their qubits, which were started here, have waited too long in memory, and so they need to discard and message their neighbors about that. And so eventually, everything works out, and each of the repeaters are able to swap, and we successfully get entanglement. So you saw that it was a little bit of a challenge to get there, and this was actually quite a good run. It can take a lot longer. It can take quite a while, but using this kind of approach, you can kind of get statistics on how long you expect it to take given a set of parameters.